Okay, so problem 2.43 in the vectors section is a problem you will almost guaranteed to see in a homework problem. So I'm going to take you through step by step and show you how to do it. Basically, the first thing to look at is you have this kind of crazy drawing of this support, and it looks confusing, but it's really pretty simple. You can draw a pretty straightforward free body diagram for it. So the way it's going to look is just like this. Just here's our little support, and we have 4 different cables coming off of it. There's our 4 cables, and each of these cables has an angle associated with it, so I'll draw them right over here. This angle is 51 degrees. This angle is going to be 40 degrees. This angle is 22 degrees. And this angle is 9 degrees. This is going to be T4, T3, T2, and T1. And it also gives you at the beginning of the problem that all these T's are equal. So all the magnitudes of these T's are equal. So magnitude of T1 equals magnitude of T2 equals magnitude of T3 equals magnitude of T4. Okay, so this is basically what you started out with. Next thing you need to do is recognize that there's got to be reaction forces holding this thing in place. So we're going to have a reaction force in the X and a reaction force in the Y. And, in addition to all this, we also were given that the tensions need to exert a total force of 12,500 pounds. Okay, so let's take a look at this. So let's look at this requirement really quickly. These tensions need to create a force such that the magnitude of the reaction force is 12,500 pounds. So if you look back a little bit, you'll remember that the magnitude of a force is going to be equal to the square root of its components squared. So the reaction forces are going to come from Rx and Ry. So we know that Rx squared plus Ry squared needs to be equal to 12,500 pounds. Alright, this is our starting point. So we know this, but we don't know what Rx is and we don't know what Ry is. So what we're going to do is solve for these two in terms of T. So we're going to so all of these can be equal to a common T, since they're all equal to the same thing. So next step, we need to figure out what's going on in here. So if you remember, the first thing you always do when you're looking at these kind of problems is you're going to sum the forces in the X and sum the forces in the Y. So we'll start with the X. Sum the forces in the X. So start with T1, and remember, multiply by cosine of 9 degrees, because that's the X component of this vector. This is broken up into 2 vectors, X and Y, plus T2 cosine 22 degrees plus T3 cosine 40 degrees plus T4 cosine 51 degrees. Minus Rx has to be equal to 0 because we're dealing with statics. Remember that. Okay, so let's solve a little further. We know that T1, T2, T3, and T4 are all equal to this common T, this magnitude right here. So we can really replace all of these with T. And when we do that, we can pull out the cosine from each one of these terms and just multiply the whole sum by T. So we can write it like this: t times cosine of 9 degrees plus cosine of 32 degrees plus cosine of 40 degrees plus cosine of 57 degrees. And then we can move this Rx to the other side and set this whole thing equal to Rx. So now we know that Rx, when we put these all in our calculator and figure it out, it's going to come out to 3.258T. So now we have Rx. Now we can put this Rx back into our original equation. Alright, next step. Got to solve for the y's. So some of the forces in the y's. Same thing. In fact, I'm going to skip this first step and I'm going to move right on to this step right here. So t times, and remember we're dealing with y, so we're going to be multiplying by sine of 9 degrees plus sine 30, oh, sorry, this is 22 degrees plus sine 40 degrees plus sine 57 degrees minus ry, because you know it's got to be in the opposite direction as those forces, is going to be equal to 0. So when we solve this further, we're going to get ry equals 2.061 t equals 2.061 t. I'll erase that really quickly. Okay. All right. Next, so now we have Rx and we have Ry, and we can plug them both back into this formula. So let's go back to purple really quick. So we know that 12,500 pounds has to be equal to square root. Now we'll plug in our Rx and our Ry. So Rx is going to be 3.258t squared plus 2.061 t squared. So when we solve this out, square root of this is going to be 10.615 t squared plus, remember this squared distributes over both the 2.061 and the t, so this one's going to come out to 4.24 t squared. So add these two together and we're going to get 14.858 t squared. And then remember, you can separate the 14.85 square root from the square root of t squared. So taking the square root of 14.85, it's going to give us 3.85, and then taking the square root of t squared is just going to give us t. So now we can move up a little bit and go to the final part, which I'll do in pink. So we know 12,500 pounds needs to be equal to 3.85 t. So divide both sides by 3.85. That's going to yield that t is equal to 3,242 pounds. That is your final answer. That is the t necessary. If these t's are all equal to each other, if t1 equals t2, t3, t4 is all equal to a single t, that is the t that, given these angles, will yield a reaction force of 12,500 pounds. Hope that made it a little clearer. Let me know if you have any questions, and good luck.